In this video, we are going to convert improper fractions. So what is an improper fraction? Well, there's an improper fraction for you. The numerator is larger than the denominator. An improper fraction is going to be equal to or greater than 1, right? But a normal fraction always tells us, I say normal, let's say a proper fraction. A proper fraction always represents something less than 1. So if we have something that's equal to 1 or even greater than 1, that's an improper fraction and we need to convert it. We'll convert it into a mixed number. So let's take 14/5. So what does that look like? Well, I always like to think of pizzas, so let's think of these as strange pizzas. Okay, and after the party, we have some pizza left over. Mom had purchased 5 boxes of pizza, and then people just ate what they wanted from each of the 5 boxes. And you can see we still have 3 pieces left in the first box, 2 pieces in the second, 4 in the third, 3 pieces in the fourth box, and 2 pieces are left in the last box. And so altogether, there's 14 pieces, or 14 slices of pizza. There's 14/5. Now, why is it fifths? Is it fifths because there's 5 bars or 5 boxes of pizza? No. It's fifths because the pizzas or the bars are cut into 5 pieces each. And we have 14 pieces all spread out. Well, we want to be able to take all of those and sort of shove them into 1 bar at a time. It's sort of be like if you had that leftover pizza, Mom wouldn't just shove all those boxes in the fridge. She would start regrouping them, right? And putting them together so that they fit in the fridge. So we can take the light blue and the brown, we can shove those into 1 box. That makes a complete box now. How much is in that first box? We got the 3 blue and the 2 brown, and together that's 5. That's 5 out of 5. Well, I know that 5 out of 5 is 1 whole. So then we can take that darker blue and that lighter brown. Well, not even all of them. We could take 1 of those lighter browns. We'll shove those together. Now that makes a complete box. Now that's 5 out of 5 pieces that are filling up that second bar there. And then we had 2 more of the light browns, and we had 2 of the beige, and now we can put those together. We didn't fill up that third box, but that's okay. We filled up most of it. Right, so what do we have here? Well, we have 2 whole boxes filled in, or 2 whole bars filled in, and we have 4/5 left over in that last one, 2 and 4/5. Now that's much tidier, and those 3 boxes hopefully can fit into the fridge, but those 5 weren't going to fit in the fridge. Let's not be crazy. All right, so how do we do this mathematically instead of always having to draw a picture and then move, colors around? Well, I like to start with the whole number. So what was the whole number back over here? The whole number was 5 out of 5, 5/5. So when a numerator and a denominator are the same, that's equal to 1. So 5/5. So if we take 5/5, I know we still got a lot more pieces to go. So what about 5/5 and 5/5? Now how much would that be? If we added 5/5 and 5/5, we'd get 10/5. All right, 10/5, but we need 14/5. So 5 plus 5 is 10, and how much more do we need for 14? 5 plus 5 plus what equals 14? 5 plus 5 is 10 plus 4. Plus 4 would be 14. So the leftover fraction is 4/5. And again, count those blue numerators. 5 plus 5 plus 4. What does that give you? That gives you 14. All right, and then of course the denominators will stay the same because we add denominators, or we can add fractions when the denominator is the same. All right, so what's our mixed number? Well, how many wholes do we have? We have 1 there, we have 1 there, so that'll give us 2. And then we have the 4/5, which is left over. So there's 2, and there's 4/5. All right, here we go. Let's do example 1 here. So remember, we're not going to do it with a picture. because it's a lot of pieces and it's a lot of moving around. Let's do this mathematically. Remember, you got to think of ones first. And since our denominator is 8, just think 8/8. 8/8 is 1. Well, how many 8s can we go before we hit 27? Let's see. We've got, 1, of course. That's fine. And then we could do 2. 8 plus 8 is 16. Plus another 8 is 24. Could we do another one? 8, 16, 24, 32. Oh, no, that's too much. That's too much. So 8 plus 8 is 16, plus 8 is 24. How much do we still need to hit 27? 3. So 24 plus 3 is 27. And the denominators, of course, all stay the same. So how many whole numbers do we have? How many big giant ones do we have there? We have 3. And we have the 3/8 that is left over. All right, how about another one? All right, remember, you just immediately look at the denominator, and you think, oh, how much is a whole? Well, what would a 1 be? Well, 3/3. Okay, so we're going to start with 3/3. Now, could we do another 3/3? 3 plus 3 is 6. Okay. So that's good. Could we do another 3? 3 plus 3 plus 3? That's 9. That would be too much. All right, 3 plus 3 is 6. How many more do we need to hit 8? 2. 6 plus 2 is 8. So how many 1s do we have? We have 2 1s, and we have left over 2/3.